Hi everyone, today I'm going to talk about the data analytics. There are three types of them. The first one is data analytics, the second one is data mining, and the third one is cognitive computing. Data analytics. The definition is it is the science of examining raw data with the purpose of drawing conclusions about that information. Why it is important? Because you can truly change operations, prevent fraud, gain competitive edge, retain more customer, anticipate distance outbreaks, or run unlimited budget simulation. The possibilities are endless. The data analytics is reactive and proactive. Uh, Reactive is business intelligence and big data (BI). The proactive is big analytics and big data analytics. The business intelligence provides standard business reports, ad hoc report, OLAP, and even alerts and notifications based on analytics. This ad hoc analysis looks at the statistic part, which has its purpose in a limited number of situations. Big data (BI). When reporting pools from huge data sets, we can say this is performing big data (BI). But decisions based on these two methods are still reactionary. Big analytics allow you to identify trends, spot weaknesses, or determine conditions for making decisions about the future. But although it's proactive, big analytics cannot be performed on a big data because traditional storage environments and processing times cannot keep up. The last one is big data analytics. By using big data analytics, you can extract only the relevant information from terabytes, petabytes, and exabytes, and analyze it to transform your business decision for the future. Data mining. It is an interdisciplinary subfield of computer science. Is the computational process of discover patterns in large data set, involving methods at the intersection of artificial intelligence, machine learning, statistics, and database system. There are six common classes of tasks. The first one is a normal dedication, the identification of unusual data records that might be interesting or data errors that require future investigation. Second one is association rule learning. It searches for relationship between variables. The example of the ARL, a supermarket might gather data on customer purchase habits using association rule learning. The supermarket can determine which products are frequently bought together and use this information for marketing purpose. This is sometimes referred to as market basket analysis. The third one is clustering. This is the task of discovering groups and structures in the data that are in some way or another similar, without using non-structure in the data. Classification is the task of generalizing non-structure to apply the new data. For example, an email program might attempt to classify an email as legitimate or as spam. Rigorous attempts to find a function with models the data with the last arrow. The last one is summarization, providing a more compact representation of the dataset, including visualization and report generation. Last one is cognitive computing. It makes a new class of problems computable. It addresses complex situations that are characterized by ambiguity and uncertainty. In other words, it handles human kind of problem. In these dynamic, information-rich, and shifting situations, data tends to change frequently, and it is often conflicting. The goals of users evolve as they learn more and refine their objectives. For new level computing, first one is adaptive. They must learn as information change and as goal and requirement evolve. They must resolve ambiguity and tolerant, unpredictable. They must be engineered to feed on dynamic data in real time or near real time. Interactive. They must interact easily with users so that those users can define their needs comfortably. They might also interact with other processors, diverse, and cloud service, as well as with people. Interactive and stateful. They must add defining a problem by asking questions or finding additional source input if a problem statement is ambiguous or incomplete. They must remember provision interaction in a process and return information that is suitable for the specific application at that point in time. The last one is contextual. They must understand, identify and extract contextual elements such as meaning, syntax, time, location, appropriate domain, regulation, user's profile, process, task, and goals. They may draw on multiple sources of information, including both structured and unstructured digital information, as well as sensory input. Here are the resources which I found for this presentation. Thank you.